In this lesson, we're going to learn about identifying and like terms. So, by the end of it, again, you should be able to identify what are considered like terms and then be able to combine them into a single term if they are like terms. So, the first thing we have to identify is what is a term? Well, a term is either a constant or the product of a constant and a variable. So let's remind ourselves what constant is. Again, a constant is just any number. Let's say 5. 5 is a constant because that number doesn't change. It's just 5. Okay? So that is a term by itself. Another term would be, say, 3x, because it is the product of a constant and a variable. So that's a term right there. Or let's say it's n cubed. That is the product of a constant and a variable. The constant happens to just be 1, but it's the product of a constant and a variable that just happens to be raised to the power of 3. So if you see anything like this, whether it just be a constant or a constant with a variable, that is what we call a term. So the next thing is a coefficient. And what is a coefficient? Well, the coefficient is the constant that multiplies a variable in a term. These might be coming off my recording. Give me 1 second here. Constant and a term. Okay, so again, coefficient is the constant that multiplies a variable in a term. So if we go back to those last examples, say 3x, the coefficient of this is 3 because it is the constant that multiplies a term. Similarly, if we looked at n cubed, the coefficient of this is actually 1 because, again, you can put that 1 out front, and 1 is the constant that multiplies this variable in the term. So, again, if we look at this, 3x is the term, 3 is the coefficient, x is the variable. N cubed is the term, 1 is the coefficient, n cubed is the variable. So that gets us to what like terms are. So the definition of them: if two terms are constants or have the same variable raised to the same power, the terms are called like terms. So again, let's say they're both constants. So say the terms 3 and 5 end up in an expression. Well, those are like terms because they both are just constants. Another example of like terms would be, say, 3x and x. Those two, I'll put here, like terms. These two are like terms because they're the same variable raised to the same power. Again, x and x, that's just raised to the power of 1. Another example would say 7n and 7n to the cubed and 8n cubed. These are like terms because they have the same variable raised to the same power. So let's say 3 and x. These would not be like terms because 3x doesn't have a variable on it, where x does. It just happens to be x. What about, so not like terms. What about 3y and 2y squared? Are these like terms? Well, no, they would not, because if we notice y and y squared, yes, it's the same variable, but it's not raised to the same power. So for this reason, these are not like terms. And just say another example would be 7n and 4y. These are obviously not like terms because they just have different variables altogether. So these are all examples of, again, these are examples of like terms, these are examples of non-like terms. And again, you just got to remember it's two terms who are either both constants or have the same variable raised to the same power. So why do we need to know all this? Well, we need to know it because we need to combine like terms, okay? So let's say we just have this mess that looks like this. So this is a very long expression that can be broken down into something a lot simpler. But the only way we know how to break it down is if we know how to combine like terms. So how do we do that? Well, the first step is identify like terms. So what are the like terms in this expression? Well, our like terms are, let's say, 2x and x squared. That's one like term because they have the same variable raised to the same power. Another set of like terms would be 3x and 4x. Again, these are like terms because they are the same variable raised to the same power. In this situation, it's x raised to the 1. And then the final set of like terms are 7 and 5 because these are just simply constants. So again, the first step is identify like terms in the expression. So the second step is to rearrange the equation so that the like terms are right next to each other. So we'll just start with the x squared. So we have 2x squared plus x squared. That is those ones. Then the next ones, let's go plus 3x plus 4x. And then the last one is plus 7 plus 5. So step 2 is rearrange the like terms so that they're right next to each other. And then the last step, step 3, is just simply combine the like terms. And that is just conducting the operation. So because they are like terms, we can combine them. So what is 2x squared plus 1x squared? Well, that would just be 3x squared. What is 3x plus 4x? Well, that's just 7x. We're just adding the coefficients or doing whatever operation to the coefficients as states. The next one was 7 plus 5, well, just 12. So by combining like terms, we turn this long, ugly equation into something that's a lot shorter and more compact. And that is the goal of combining like terms. So I'll give you guys an example to work on and see how you can do on your own. So say we are given this equation. These all are of the variable x, just in case you can't read my handwriting. Okay, go ahead and work on this and see how you do. Okay, now let's just go through it. So again, step 1 is identify the like terms. So we have an x squared terms, we have x terms, and we have just simply constants. So first step is done. We've identified the like terms. Second, let's rearrange them accordingly. 7x squared, 3x squared plus 7x squared. Okay, now we move on to the x's. So 7x plus 9x. Now let's move on to the constants, plus 9 plus 8. And step 3, just simply combine the like terms. So 10x squared, which is just adding up the coefficients, so that's 16x, and then the constants, 17. So we've turned this long, ugly equation into this shorter equations by combining like terms.